6.6. Can you believe they want you to find all the zeros and they're not going to even give you the first one? How do you start this thing out? Well, remember, we're going to make a list of the factors of the constant, and divide it by the factors of the leading coefficient. And that will give us the only options, really. But make sure you take a plus or minus. So factors of the constant divided by factors of, I'm just going to put LC for La Crosse Central, or leading coefficient. And here we go. So the constant is 50, or negative. It's technically negative 50, but we're going to have a plus or minus in front of this anyway, so let's call it positive. The leading coefficient's 1. So let's list the factors of 50. 1, 2 goes into it, 3, 4, 5 goes into it, 6, 7, 8, 9, 10 goes into it. I don't think I missed any there. Well, I'm not done yet. So I don't think I missed any yet. 5 times 10 is 50, 2 times 25 is 50, and then 1 times 50 is 50. So you can kind of use the initial factors to help you find the bigger ones. And then the factors of 1 is just 1. So now divide. 1 divided by 1 is 1. So it could be positive 1 or negative 1. 2 divided by 1 is 2. Positive or negative 2 could potentially be a 0. And so on and so forth. When we divide by 1, obviously it's just that number. So here's my list of potential zeros. Boom. Let's try the next one. The constant is 3, and oh, this is funny. The leading coefficient is 3. So let's list the factors. So the factors of 3 are 1 and 3, and the factors of 3 are 1 and 3. So I'm going to start with the 1 and divide it by 1, which is 1. And I'm going to take the 1 and divide it by 3, which is 1/3. Then I'll move over to the 3 and divide that by 1, which is 3. And then I'll take the 3 and divide it by 3, which is 1. So I get that one again. So here is a list of my potential zeros. My constant here is -1, but I'm going to put down 1. And my leading coefficient is 2. So let's list the factors. I should probably write the word factors in front of this. So let's factor this. So factors of 1 is 1. Factors of 2 is 1 and 2. So now I'm going to take the 1 and divide it by 1, which is 1. But again, it can be plus or minus. And I'm going to take the 1 and divide it by 2. That gives me 1/2. So plus or minus 1/2 for number 3. Last but not least, our constant is 20, so let's factor 20, and then we're going to divide that by the factors of our leading coefficient, which is 1. Factors of 20, 1, 2, 4, 5, 10, and 20. Factors of 1 are just 1. So we divide by 1 again, it's silly, so it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and finally, last but not least, plus or minus 25. There's our list of potential zeros for that polynomial. State the possible rational zeros for each function, then find all zeros. So we're going to do what we just did, stating the possible rational zeros, and then we'll actually go about trying to find them by picking one of those potential zeros and putting it into synthetic substitution and seeing if we actually get a 0 out for our remainder. And then we know that we can keep factoring further. So here we go. Our constant. So we're going to factor the constant, which is 2. And we're going to factor the leading coefficient, which is 2. So the factors are 1 and 2, and 1 and 2. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 2 divided by 1 is 2. 2 divided by 2 is 1. So that's repeated right there. I don't need to relist that. It'd be redundant. So there's my potential zeros. Now use synthetic substitution to see when we get a remainder of 0. So I'm going to try positive 1 first. Coefficients are 2, 1, negative 5, and 2. Make sure you keep track of that negative. Drop down your leading coefficient. I'm just going to do it. It's funny. I feel like I do it faster when I actually talk through what I'm doing. And maybe I should be doing that. Hey, I got a remainder of 0, as long as I didn't screw that up. You know what you could do is you could take this 1 and shove it in place of x in this polynomial and make sure you get a 0 out just to double check it. I'm going to hope I didn't screw up there and go with it. So, because I got a remainder of 0, that means that this 1 is definitely a 0, meaning that a factor is x minus 1. Because if the 0 is 1, if 1 is a value of x that makes the function equal 0, that comes from a factor of x minus 1. So then here's my constant. There's my x squared. So I've got 2x squared plus 3x minus 2. Want to know what values make this become 0? Remember, we have this polynomial right here. We want to try to factor that thing further. Now, in our last practice, we didn't do a whole lot of when there was a leading coefficient. So now we want to look for numbers that multiply to, we have to multiply the a and the c together. We want to look for numbers that multiply to negative 4 and add to 3. So that gives us 4 and negative 1. So when we put that into our factored form, we have to divide those numbers by the a value. And then you try to reduce this fraction. This one right here you can, it's x plus 2. When there's still a denominator, even if it's simplifiable, then if there is still a denominator down here, you bring that out in front. So it's going to be 2x, and then minus 1 comes straight down. So, and then don't forget to bring down your x minus 1. I've kind of slacked off on that over here. X minus 1, x minus 1. So this right here in yellow, if you were to multiply that all together, should equal this initial polynomial right here. Isn't that crazy? We were able to factor that thing down. So then we got to figure out what values of x make the polynomial be equal 0. So let's just look at it factor by factor. So 1 is a solution here, negative 2 is a solution here. And then careful with this one. We want to know what value of x makes 2 minus 1 equals 0. You know, if you have to do the good old-fashioned solving, do it. Right? Algebra 1, but it gets you the right answer. Divide by 2, so you get x equals 1/2. So 1/2 is the other solution. We scroll up so you can kind of peruse the work there. How does that look to you? Looks beautiful to me. Amazing. Alrighty.